everybody, Mr. Covey here, and this is the second video in the rational functions unit. So this is just more practice with rationals, except we're going to encounter kind of one special situation to be on the lookout for. If you, after watching the first video, had some issues with getting the shape correct, like kind of where the graph goes after figuring out all the characteristics, I'll give you a little more advice about that here. I know that's a little tricky, so I'll give you a little more advice about that today. So we come up to this rational function, and again, first step is always going to be to factor it. So I'm going to factor the numerator. I'm going to factor the denominator, take out a 2, x squared plus x minus 2. So I'm going to factor that. And what you see here is something weird that we haven't seen before, which is we have a factor in the numerator that's the same as the factor in the denominator. Now I know what you're thinking back to your AAA ATH days. Hey, can I just cross those out? And you can just cross those out. Okay? Graphically, something a little weird happens. We'll talk about that right now. So my vertical asymptote only happens at x equals 1 now. That x plus 2 that I crossed out, that doesn't count as a vertical asymptote anymore. What that does contribute to is something called a removable discontinuity in my graph. Okay, I know that's a fancy weird word, and we'll talk a little more about what that vocab means later in the year, actually. But what it really is in the graph is it creates a hole in the graph. So basically you can cancel it out and ignore it, except just at the point x equals -2, you get a hole in the graph. It's a super small hole. If you type this into your graphing calculator, you wouldn't even see it. If you typed it in Desmos, you wouldn't even see it. It's a super tiny hole, just at that one point. Okay? So that hole happens at x equals -2, because that's where x plus 2 would be 0. And that can figure out the y coordinate that happened by plugging in x equals -2. So I plug in x equals -2, I get -1 on top, and on bottom I get 2 times -3, which would be -6. So it happens at -2, 1/6. I have a hole in my graph, just a hole sitting there. I'm going to graph that real quick. So at -2, 1/6, I have a hole. I know what you're thinking. How do you graph a hole? You just do it like this. It's not filled in because it's a hole in the graph, so I don't want to fill it in. Cool? Holes are points, or their lack of points, and that still affects our domain. So our domain, we still can't equal 1, and we can't equal -2. So I'm going to do my domain, -infinity to -2, pick right back up at -2, but don't hit it, go to 1, can't hit 1, but I can pick right back up after 1, there's my domain. So you know how previously we were saying domain and vertical asymptotes go together? We're now adding on a special situation, which is holes in the graph, removable discontinuities, that also tie together there. Okay? So I should throw in my vertical asymptote at x equals 1. Sorry there. Cool. That's really the only new thing. Okay? So my horizontal asymptote, I have same degree in the numerator and denominator. They're both squared. Invisible 1 there. So my horizontal asymptote is going to be y equals 1/2. So at 1/2, I'm going to have a horizontal asymptote. Stick with me, it's a little hard to write on here. End behavior, well, I have a horizontal asymptote. So as x goes to infinity, my y is going to go to that horizontal asymptote. As x goes to -infinity, my y is going to go to that horizontal asymptote. Okay? 0 is x-intercepts. I'm going to plug in 0 for y. If I plug in 0 for y, remember I'm only looking at the numerator. So I'm looking, hey, when does x plus 1 equal 0? Well, that happens at -1. So -1, 0 is my only x-intercept. I crossed out the x plus 2, so that no longer contributes as an x-intercept. And I need my y-intercept. You find a y-intercept by plugging 0 in for x. If you plug 0 in for x, you get out 2 over -4, which is -1/2. So 0, -1/2 is my y-intercept. Since this graph only has one vertical asymptote, it's a little bit easier to graph. Okay? So I can tell pretty clearly that the graph's going to look like this. It goes through the hole. That's the point. That's a hole in the graph. So the graph goes right up there. It just has an invisibly small hole. We draw it a little bit bigger. Oops, and that should be getting closer to that asymptote there. Sorry, mine's a little wiggly. Now the only thing I don't know is what happens over in this chunk of the graph, and I do need to plug in a point or two to figure that out. Okay, so I just got to decide what happens over here. I'm going to plug in some points. Okay, so if you had confusion about how to figure out what is happening, maybe it would help if you made a little table. Okay, so I'm going to make a little table with x's and y's. Throw back to middle school. I'm going to pick some points over here to kind of try and see what's happening. So maybe I'd pick x is 2 and maybe x is 5. Really all I'm trying to decide is whether the graph probably looks like that. Something like that maybe. Or maybe it looks something like that. I don't know. Okay, so I'm just trying to kind of decide which one of those is right. Okay, if you're plugging points in, a piece of advice I'd have is to plug them into the factored form. Okay, and in the case of a one with holes, you can plug it into the simplified factored form. So I can just plug it into x plus 1 over 2 times x minus 1. Okay, 2 plus 1 is 3. 3 divided by 2 times 1, that's 3/2. 5 plus 1 is 6. 6 divided by 2 times 4, 2 times 4 is 8. 6 divided by 8, 3/4. Okay, so if I go to my graph here, at 2, I'm at 3/2. At 5, I'm at 3/4. Those extra 2 points convince me that the graph looks like this. It's getting close to the asymptote there, and it's going to go up closer to that vertical asymptote. You know your graph has to approach the asymptotes. That's what the asymptotes are. They're things that your graph approaches. Okay, so if in the previous problems you're a little confused, making a little table to help you get those points is what you should do. Yeah, and now I'm done with that one. Maybe put a little additional note here if you want about removable discontinuities. In other words, holes in your graph. If you jump to this one, I'm going to pause and I want you to get started, and then you can unpause and kind of see where you're at. So why don't you start doing some of this? When you get stuck, unpause. Okay, I'm kind of mostly done with this, but I'm going to run through what I did and finish it up with you guys. Okay, so I factored fully, and I got this, and I know what you're thinking. It doesn't really look like anything crosses out on the top and the bottom. It doesn't look like there's a hole. But actually, you can cross out an x. So if you cross out that x, it cancels out with this x squared and just leaves it as an x. So there actually is a factor that cancels out in the top and the bottom, and it creates a hole. That hole happens at 0. To figure out the y where that happened, I plugged 0 into this, and I got 0 over -6, so I got 0, 0 was where my hole was located. The remaining factors in the denominator told me the vertical asymptotes. Both of the vertical asymptotes, as well as the x-coordinate of the hole, were all restrictions on my domain. So my domain is kind of broken up into 4 chunks. Up to -3, -3 to 0, 0 to 2, 2 to infinity. The degree of the numerator and the top denominator were the same, so I did 2 divided by 1 to figure out that the horizontal asymptote was at 2. So then my end behavior was as x goes to -infinity, y goes to 2. As x goes to infinity, y goes to 2. To figure out my zeros, Again, I set my numerator equal to 0. That happens at -2 and 0, except for I already have a hole there. Okay, so don't forget about that. It's not actually a point on my graph. To figure out my y-intercept, I should add that -2, 0 to my graph there. To figure out my y-intercept, I plugged in 0 for x, and I got 0 over 0. I plugged it into the original one here. So I got 0 over 0, and I was like, can't have 0 over 0. That's undefined. There is no y-intercept. Okay, and that makes sense because I have a hole at my y-intercept. Now to the graphing part. I'm pretty confident the graph looks something like that. And again, it skips over that hole. That's the whole point of the hole. Now what I don't know is what it looks like over here and over here. Again, there's really two options for both of them. It looks like this or like this for this one, and similarly for the other one. All I'm going to do is plug in a few points. Okay, I'm going to make a little table. Here's my little table. I know this takes a little time, but that's all it takes is time. I'm going to plug in -5, and I'm going to plug in 5. Okay, take a second to plug those in. I plugged those in. Those are the fractions I got. Again, this is rough estimate. So -5 is at a little more than 2, so I put that point there, which convinces me the graph looks like this. At 5, it's a little less than 3, so I put the point there, which convinces me the graph looks like this. Okay. I know it's a little time consuming. I do need you to be able to do that. Let's slide on to the third one. I want you to try this one entirely on your own, please. So go ahead, pause, do this problem, unpause, and we'll go back over it. Okay, so I'm not 100% done. I was going to finish it up with you guys, but I factored. I actually had two things cross out. I had an x on top and an x on bottom, which gave me a hole at 0, and then an x minus 1 and an x minus 1, which gave me a hole at 1. Figured out the y-coordinates for those holes. They're right there. I still had an x plus 3 in the denominator, which gave me x equals 3 as a vertical asymptote. My domain had to exclude the vertical asymptote, as well as both of the holes. Horizontal asymptote looked at the ratio of the coefficients. It was cubed over cubed, so I did 1 divided by 2. It told me y equals 1/2 was that asymptote. Helped me with the end behavior. Again, for zeros, you can actually just look. Well, there might be some questions about this part. You can just look at the simplified version. You can look right into here and see, oh, just -4. That's going to make the numerator 0. Again, zeros are x-intercepts. Fractions equal 0 when the numerator is 0. Y-intercept, if you plug in 0 for x, you get 0 over 0, which is undefined. There is no y-intercept. I don't even need to make a little table. You can if you want. I'm confident that because of that red guy there, I can do this different color. Because of that red guy there, my graph looks like that over here. Sorry, my graph's a little shaky. And because, remember, your graph actually has to go through holes. So I'm confident that it comes up to these holes, hits the hole, and it's got to cruise up there. And that's what my function looks like. That concludes the second video. You should be in good shape to do those second set of practice problems. Thanks.